This video is designed to introduce you to homeostasis. Remember the story of Goldilocks and the Three Bears? You know the one. Goldilocks enters the house of the bears and tries to make herself at home. It isn't as easy as you might think. You see, it turns out that Goldilocks is very particular and has a very narrow range for what makes her comfortable. Her porridge cannot be too hot or too cold. Her chair cannot be too big or too small. And her bed cannot be too hard or too soft. Everything needs to be just right. Our planet Earth is like this. We are the perfect distance from the sun in order to maintain the proper balance of water, temperature, and other factors necessary for life to survive. If we were closer or further from the sun, life as we know it would not exist. Homeostasis is like this. Homeostasis is defined as an organism's attempt to maintain an internal environment within a specific range. Homeo means similar to, while stasis is a state of equilibrium. It's important for living things to maintain homeostasis in order to survive. There are multiple conditions in which organisms would need to maintain a stable internal environment in order to survive. In humans, it's important to maintain a stable body temperature, maintain a stable amount of fluid in the body, maintain a stable blood pressure, maintain a stable pH level, and maintain a stable level of glucose, which is sugar, in the body. One obvious example is how humans maintain their ideal body temperature of 98.6 degrees Fahrenheit. When body temperature begins to drop below 98.6 degrees, homeostasis mechanisms help to keep the body's temperature from dropping further. We start to shiver, causing muscle movement and releasing energy to help warm the body. Blood moves away from the skin toward the body's core to keep it better insulated so that it can retain heat. The body tries to insulate itself by forming goosebumps and having its hair stand on end. When the body temperature begins to rise above 98.6 degrees, homeostasis mechanisms help to keep the body's temperature from rising further. Sweating releases heat and helps to cool the surface of the skin as it evaporates. And blood moves toward the skin so that it could more easily release heat into the environment. Another example of homeostasis is how the body maintains a proper balance between acidity and alkalinity. The pH scale is used to measure how acidic or alkaline, which is basic, something is. The scale ranges from 0 to 14. The strongest acids have a measurement, or a pH, of 1, while the strongest bases, also called alkaline, have a pH of 14. Neutral solutions have a pH of 7, and the optimal pH level for the human body is at 7.4. One of the ways that we maintain homeostasis in regard to pH levels is through breathing. Breathing controls the amount of carbon dioxide in the bloodstream. We release carbon dioxide when we exhale. Therefore, when there's too much acid in the bloodstream, we can decrease the acidity and increase the pH level by taking deeper breaths and breathing faster. In addition, when the bloodstream is too alkaline, we can decrease the alkalinity and pH levels by taking shallower breaths and breathing slower. On the cellular level, it's important to maintain homeostasis in regard to the amount of fluids and minerals in the cell. In this regard, homeostasis is maintained by the cell membrane. The cell membrane controls what goes in and out of the cell. If concentrations of a specific mineral are too high inside the cell membrane can reestablish homeostasis by allowing water to enter the cell and minerals to exit. If the concentrations of a specific mineral are too low inside the cell membrane can reestablish homeostasis by allowing water to exit the cell or minerals to enter. And there you have an introductory overview of homeostasis.